Welcome to this video on our assignments in the course Competition Policy and Strategy. This video will cover exercise 11.2, so the second exercise of the 11th assignment on the topic of two-sided markets. And now in this exercise we are going to discuss an actual model of a two-sided market. In the previous exercise we were describing two-sided markets, and we were defining some some general concepts that we need in order to discuss models like these. And now we are going to have an actual model that we will analyze and find equilibria in, right? So in this exercise, the model is as follows. We are going to assume that there is a monopolistic platform and that this platform serves two groups of users. There will be one group A and one group B. We, in addition, know that the platform operator will collect a fixed fee, not a variable fee, but a fixed fee. We know this because this is capitalized letters, MA and MB. So the M referring to the fee of the respective markets, side of the market. We furthermore know that there is a unit mass of users from each group, and we know that the utility function of both users, which in the first place looks identical for both groups. So we have capital U with an index I, referring to the overall utility for a user of group I, where of course I can take value A or B. And now this overall utility of user of group I is comprised of three elements. We first have an intrinsic utility, which we will call lower U with an index I. This conceptually refers to the intrinsic utility that a user gains simply from using the platform. Therefore, we call it intrinsic utility. User simply gets it by participating on the platform. Then the second part of the utility function consists of some factor gamma multiplied with n. Gamma I multiplied with nj. N refers to the number of users from group J, in this case nj. And then there is some factor gamma, which we will find out should lay somewhere in the interval between 0 and 1. But in general, what this captures is that there is some positive spillover effect, some positive utility for a user from group I that is sourced in the number of users from group J. All right? So the larger the number of participants from group J, Nj, the larger the utility of group I. All right? So there is this positive external effect of the participation of users from one group onto the utility of the respective other group. And this, of course, goes for both groups, right? Index I, index J can be interchanged. And then finally, the third and final part of this utility function is, well, we have to consider that user I, or users from group I, have to pay some fixed fee, capital M I, in order to participate on the platform. And this fee, of course, has a negative impact on the utility that the user gain from using the platform. All right, so we furthermore assume that the intrinsic utilities, so this first part, the lowercase ui, that this utility is uniformly distributed in this interval between 0 and some upper limit, which we call vi. We already discussed this last part, so let's just quickly reiterate. This parameter gamma I measures the strength of this indirect network effect acting from group J to group I, and where Nj is the number of users from group J. already discussed this part. Now, for your information, of course, this exercise is taken from one of the textbooks which we use throughout this lecture. In this case, it's taken from Belflam and Peit's Industrial Organization. Yeah, you will find the exact quotation in our slides. This in particular is exercise 22.2. And just as an aside, in case you're not satisfied with my explanations, you can always have a look into the textbook itself, where the authors provide a solution to this exercise as well. All right, so let's dive right into this. In task A, we are going to determine the number of participating users from group I as a function of the number of participating users from the other group. So what we are looking for is some function ni as a function of nj. Ni of nj is what we are looking for. As a note, so there's a hint on the slide. We are asked to first determine the indifferent user, that is the user for whom this overall utility of participating in the platform, capital UI, is exactly equal to 0. All users for whom the overall utility of participating in the platform is weakly larger than 0 will participate in the platform, will use the platform. So this indifferent user, or this indifferent value of utility, provides us with the border between participating and not participating, and can therefore inform the number of users of the platform. So, yeah. Right, that's exactly what's written in this last half sentence. So the number of users of the platform from group I is exactly equal to the maximum utility that a user may get from using this platform minus this marginal utility, this indifferent user, minus the utility of the indifferent user. And the logic behind this is, well, consider this to be the overall of the interval of achievable utility that a user may gain from participating in the platform. Well, then the maximum possible utility that you may gain is what we define as the upper limit of this intrinsic utility of any user. And then somewhere along this interval where this is the least possible utility a user may get, somewhere along this interval what we will find is some capital UI equal to 0, right? And now, because this is the indifferent user who will just barely participate, simply by assumptions we say, well, if they're indifferent they may as well. Somewhere between this user and this upper limit we find the number of users of this group Ni. So this of course is only true because we know first that there is a unit mass of users from each group, and second of all because we know that this intrinsic utility lower UI is uniformly distributed between 0 and Vi. Using these two information, we can find out exactly this, and that is, well, the number of users from group I that will use the platform is exactly equal to this difference between the maximum possible utility that a user may get from participating and the indifferent user, the user that is indifferent between using and not using the platform, or technically, mathematically speaking, the user for whom capital UI equals 0. All right. Now we can use this indifferent user, this indifferent user of the group, this indifference condition, where we can use it in order to find something out about the intrinsic utility of this user that is exactly indifferent. And that is because, well, if we have a look at the utility function, let me just go one slide back over here, and now we say, well, what are the properties of those for whom this equals 0? Well, we can then rearrange this, bring these two terms on the other side of the equation and have some statement that reads lower UI, so intrinsic utility of group member I, members of group I rather, is equal to exactly these two, the difference between these two expressions, so formally mi minus gamma I times nj. And that is exactly what is written in this hint, right? So what we are doing here is, we are considering the difference between the utility of a user group who has the highest possible intrinsic value vi minus exactly this indifferent user, where we have already made use of this property that for the intrinsic user capital UI equals 0. So for the intrinsic user lower UI equals this expression, which I have lined out on the previous slide. All right. So we have talked about the participation constraint for group I, so the net utility must be weakly larger than 0. From this it follows that the intrinsic utility must be weakly larger than this expression. Of course, now in the border case, in the indifference case, this weakly inequality becomes an equality. So we have this boundary condition which we have talked about. And then from the fact that there is a unit mass of members of each group, we can use this difference between the largest possible intrinsic utility and the intrinsic utility of the indifferent user in order to find the proportion of users that is in this that is actually participating in the platform. So from this it follows that the number of users ni equals vi minus lower ui, where we can substitute for lower ui the expression from the utility function. So what we get is vi plus gamma I times nj minus mi. And with this, of course, we have an expression that provides the number of users from group I, ni, as a function of the number of users from group j, nj, which is all that we were asking for in this task, ni as a function of nj. Now I can promise that this was the most difficult part of this whole exercise. Once we have established this function ni of nj, as it is written down here, the rest of this exercise unfolds itself, as you will see in a second. So, in the next step, we are asked to solve the system of equations na of nb and nb of na worked out earlier. Alright, so we have ni of nj. Of course, we can plug in both of these indices respectively, right? So we have already found both of these. We just have to plug in the correct index for I and j respectively. Now we have two equations, one for each number of participants of the group, of the respective group. Right. We are now asked to rearrange this or solve this system of equations so that we get the number of participating users on two sites resulting as a function of the access fee MA and MB. So basically what we are asking for is, well, have a look at this function Ni of Nj and have this function be independent of the users of the respective other site by substitution. All right, so we use Ni of Nj, plug Ni of Nj into Nj of Ni, and if we do so, we result with a function where Ni does not anymore depend on Nj, but rather on the parameters that defined Nj. All right, so mathematically what we are doing is we are plugging, for example, Na of Nb into Nb of Na, so we get Nb of Nb. That's something that we can solve for Nb, and that looks like the following. So, as promised, we are simply substituting Na for Nb, so we are plugging, for example, one way would be to plug in Na of Nb into Nb of Na, simply substitute Na for this expression that we derived earlier. After that, we are rearranging this expression so that the only n in the expression is on one side of the equation. So we get the number of participants of group A as a function of all other model parameters that are not a number of participants. All right, so if we did this for group A and we substituted Nb into Na of Nb, we get this expression, which is too complicated to read, but you can all read it from the slide, right? And of course, the exact same expression, but with interchanged indices, then is the result for Nb. So we don't have to do this all over again, but we can rather argue that by analogously or by symmetry of this whole model, because both groups have the same utility function by assumption, we have the same result with simply interchanged indices. All right, so that's the first part of the exercise where we were asked to solve the system of equations and work it out so that the number of participants of users, participating users, results as a function of the access fees MA and MB. Done. Now, the subsequent question is, why is it reasonable to conclude that both of these spillover parameters, gamma A and gamma B, were, of course, just as a reminder, the parameters capturing how strong the spillover parameter is, the spillover effect is from one group onto the other group. Why is it reasonable that both of these parameters are smaller than 1? Because in theory, of course, they could be larger than this. Well, it is reasonable, or there's multiple ways to argue this. We decided to argue based on the effects that a change in the participation fee has in the number of users that has to pay this participation fee. Okay, so so we are looking at the partial derivative of the number of users from some group, starting with A in this particular case, with respect to the participation fee of group A. And of course, what we as economists would expect is if the participation fee of that members of one group have to pay increases, well, of course, the participation should decrease, right? Because you have to pay more for it. That is the expected result of the model. Everything else would be very counterintuitive and would be very hard to argue why it makes sense. So our expectation to the model, our desired property of the model would be that this derivative should be smaller than 0. So if a larger entry fee for some group would result in fewer users of the platform of the same group. Now, for parameters that are in this interval, this property holds, right? However, if the product of these two becomes larger than 1, so however, if gamma A times gamma B is larger than 1, this property is no longer holding, right? If this happens, if this product becomes larger than 1, well then this partial derivative is larger than 0. So economically not plausible. So what we need is that this product stays smaller than 0. And with this, of course, well, if this product needs to be smaller than 0, this can only be guaranteed if both of these parameters are smaller than 0 individually. As soon as we allow for one of them to be somewhere bigger than 0, we can no longer exclude a case where this product overall is smaller than 1. All right? So this would be one way to argue that, well, if this property does not hold, then the model gets or has some counterintuitive or even implausible implications. And because of this, because, well, if it does not hold, then implausible, well, then of course it's easy to, that's the basis to argue why it's desirable that this property holds, because then we get plausible implications of the model. All right. Now in the third task, we are asked to assume, or we are basically making the model a little bit simpler, because we now want to further analyze what the effects are in this model. So in order to simplify this model, let's just say, well, there is no spillover effect from group B from group A onto group B. So gamma B takes a value of 0 and just is kicked out of the model basically. Well, if we do this, then of course we do no longer need to denote this gamma A, because it's the only gamma in the model. So gamma A becomes simply gamma. And we will say that gamma is in this interval where the model keeps its desired properties. So the spillover parameter is somewhere between 0 and 1. So this means that there is a positive network effect from group B to group A, but there is no external effect from group A to group B, but not vice versa. For simplicity, we are also going to assume that this upper limit of the intrinsic utility VA or VI is the same for both groups, and it is exactly equal to 1. For this now simplified version of the model, we are going to determine the optimal membership fees MA and MB that maximize the platform operator's profits. And for simplicity, we are already given what the profit function of the operator would be. Well, we have not yet talked about any sort of costs the platform operator would have to face, so they are of course not reflected in this model in any way. So the profits of the operator are simply the sum of the overall collected membership fees or participation fees. So MA times the size of the group A, NA, and the same for group B. All right, so for simplicity, we have also already provided what the functions NA of NB and NB of NA, or even the indirect functions that were no longer depending on the member size of the other group, what these functions look like after we have applied these simplifying assumptions. So these two functions are simply the result of considering, well, or starting from the functions we have derived under task B, and then considering these simplifying assumptions and applying them. And then what's left of the model is that NA is basically unchanged, other than, well, we have of course changed VA for an 1, and NB is now a way simpler expression, simply because this whole part where there was a gamma in front of these brackets is now 0, and thereby kicked out of the model. All right, and what we can see now, of course, is still that there is this spillover effect of group B onto group A, and the same is no longer true for the other group, for group B. All right. Okay, so to summarize, under these assumptions, we are now faced with these equations, the equations we have derived under task B, simplified accordingly. All right, we are now asked to determine the optimal membership fees, MA and MB, that maximize the platform operator's profits, and the profit function is given as well. So we know we want to maximize the profits by choosing MA and MB, profit maximizing, so this is our strategic variable. And of course we know that NA and NB are functions of MA and MB respectively, right? So we have to plug in NA and NB, or we can simply plug in the expressions we have derived for NA and NB, substitute for it, and then we get an expression for the profits in which there is only 2 parameters, or there are only 2 parameters, and that is MA and MB, exactly the values or parameters we want to maximize this expression over. So we are faced with a profit function that looks like this. As promised, we have simply used the expressions for NA and NB in this expression, substituted for it, and then we get this expression over here for the profits. A function that only depends on gamma, MA and MB. Now, how do we find the profit maximum in this scenario? Well, we of course calculate the or state the first order conditions of a maximum with respect to these 2 parameters MA and MB, so the participation fees. We do this by calculating the first order derivative with respect to MA and MB respectively, setting or forcing these 2 expressions to be equal to 0, and then we can use this to or we can simply rearrange these expressions until we get an expression for MA and an expression for MB, where we have MA and MB on the one hand side of the equation and nothing but numbers, and the only other model parameter gamma on the other hand side of this equation. Right? So we get the membership fees, the profit maximizing membership fees, as a function of the spillover parameter and other model parameters that are not membership fees. All right. Of course, we can now technically calculate the profits of this platform operator, even though there's not really much to gain from this expression, simply by plugging in MA and MB into the profit function, so the profit maximizing MA and profit maximizing MB into the profit function, and thereby, of course, we calculate the profit, the maximum profits of this operator, or rather the profits of the platform operator under profit maximizing strategies. All right. Right, exactly. Yeah, we were asked to find these optimal membership fees. We did that, and we were asked to calculate profits. We did that as well. All right, so let's move on to task D, where we are going to interpret these findings. We are going to answer the questions: which group has to pay the higher access fee, and why is that? How does the access fee and profit change with an increase in the network effect? What is the reason behind this? And of course, if you take a look at the results we had earlier, so the profit maximizing membership fees we already know that they only depend on this spillover parameter. So it's quite obvious that this spillover parameter is the deciding factor when it comes to the relative height of these two parameters MA and MB. So let's have a look at this. What we see is, first and foremost, that the membership fee MA is larger than the membership fee MB. This might not be as trivial on first sight, but then on second inspection you will notice that we can simply, when we are comparing these two expressions, these two membership fees, why not simply multiply with 2 minus gamma, both of them multiply both of them with 2 minus gamma, then this whole lower part of the fraction is gone on both sides, and what we are then left with is MA equals 1 and MB equals 1 minus gamma. We know, of course, gamma is positive by assumption, so what we know is, well, 1 is larger than 1 minus something positive, all right? And by that we know that overall MA is larger than MB, so the participation fee that group A has to pay is larger than the participation fee group B has to pay. So, yeah, group A experiences a network effect and therefore needs to pay a larger fee than group B, which does not experience a network effect, right? Just go back to the assumptions that we make, the simplifying assumptions we made onto the model or imposed into the model earlier, and yeah, just to convince yourself that in fact group A is the one that experiences a network effect, and because group A is the one that experiences a network effect, it makes intuitive sense, I believe, that group A also has to pay a larger membership fee. This, of course, you can even go back to the utility function itself and have a look at this and consider what happens if the spillover effect is larger for one group than for the other. And that's, of course, exactly what's happening here. And you will realize that for any given intrinsic utility of using the platform, a larger spillover effect will imply that the respective group is willing to pay a larger fee as well. All right, so an increase in the spillover effect, so a change in the network effect, increases MA even more, which is based exactly on the argument we just made, and at the same time it will increase the profits as well. Because we are talking about pricing structure, and this is now looping all the way back to the beginning of this exercise and even the previous exercise, because we're talking about pricing structure, we will observe that while an increase in this spillover effect increases the participation fee of group A, the one experiencing spillover utility or spillover effects from the presence of the other group, but at the same time it will decrease the participation fee from group B. And this, of course, is endogenous to the model because the platform operator is choosing MA and MB profit maximizing, right? So through an increase in this network effect, we will observe that the platform operator will, in order to maximize profits, actually decrease the participation fee they are asking from group B, simply because group B has a very strong, right, an even stronger network effect on group A now. So the presence of group B will increase the willingness to pay, so to speak, from group A even more, right? So the platform operator can ask for an even larger fee from group A by decreasing the membership fee of group B. All right, so the effects on the users from group A are twofold in this scenario. First, we have a larger number of participants from group B, because this fee is decreased, so ceteris paribus, more users will enter the platform. And second, we will have the increased network effect. So not only is NB increasing, but also gamma is increasing, both of which of course have an increasing effect on the utility of group A.